Hello my dear students, in this lecture I will give you some instructions on continuous time Fourier transform. In previous lectures we have continually known the matter of continuous time Fourier series, but here we will know about continuous time Fourier transform. For this we have to know the basic of Fourier transform, what are the motivation of Fourier transform. So Fourier series provide an extremely useful representation of periodic and periodic signals, and uh, that is the main thing. Fourier series, that is quite related to Fourier series too. Often, however, we need a deal with signals that are not periodic. A more general tool than the Fourier series needed in this case, the Fourier transform can be used to represent both periodic and aperiodic signals. In Fourier series, we are doing the transformations. Sorry, not transformations. We are doing we are deal with the periodic signals, but here we will deal with the both signals, periodic and aperiodic signals. And after transform, we can use to represent both periodic and aperiodic. That's the thing. Since the Fourier transform is essentially derived from Fourier series through a limiting process, the Fourier transform has many similarities with Fourier series. That means that is quite a bit similar to Fourier series, but the thing is that it has been generated from limiting process of Fourier series. Okay. Now that is the Fourier transform. In this section we will know the development of Fourier transform. The Fourier series is an extremely useful signal representation. Unfortunately, the signal representation can only be used for periodic signals, since a Fourier series is inherently periodic. Many signals are not periodic. So here we have to first of all limit the time. Here we can see there is a time period t, and it is given as infinity. But if we limit the limiting case, the period signal with period t where t is, tends to be infinity, we can use the Fourier series to develop a more general signal representation that can be used for both aperiodic and periodic signals. This more general signal representation is called Fourier transform. That means if in the limiting case of periodic signal, the Fourier series to develop a more general signal representation, that means in a more general signal representation, both aperiodic and periodic signals, this more general signal representation, that means the representation is known as the Fourier transform. Okay, so let us go to the next slide. That is the basic continuous time Fourier transform law. The continuous time CT Fourier transform of the signal x denoted fx, that is known as the Fourier transform by this interpretation of f or x. That means you can also represent it as the capital letter of this variable is given by like this x omega, that is integrating between the minus infinity to plus infinity xt e to the power minus j omega t dt. So you have to just commemorate and memorize this certain equation. This certain equation is the Fourier transform and the basic of the Fourier transform. If you want to Fourier transform a signal x, that is a continuous signal, just multiply with e to the power minus j omega t, and you know what is Fourier transform. The Fourier transform transforms a time domain to its frequency domain. Time domain has been transferred to frequency domain. Whether we will get by transformation ct, if xt, if we make the Fourier transform, that means ft, if we transfer it, we will generally get x omega. That means the time domain signal is now being a frequency domain signal, and omega is the angular frequency of the signal. And the general equation is that if you know the function of xt, then you can just put the function here and integrate with the help of e to the power minus j omega t dt. That means with respect to time. So the preceding equation is sometimes referred as the Fourier transform equation or Fourier transform analysis equation. The inverse Fourier transform, that means the f inverse x, or that will denoted as x, that means if it is x omega, and if you are giving as that is the denotation f inverse to this kind of equation, you will generally get the time domain. That means whenever you get the inverse form of it, that means whenever you choose time domain instead of frequency domain and want to transfer a frequency domain signal to time domain signal, that will generally go through to the inverse Fourier transform, and that can be given as this equation, that is the inverse equation, 1 divided by twice pi, and there is integration of minus infinity to plus infinity with this x omega that has been given to certain kind of equation that has been given. So the function of the frequency x omega here is the notable. There is one thing is quite notable. You can see that there is minus e to the power minus j omega t, but after making it inverse, that converts to e to the power plus j omega t. So these two equations are quite similar, but the thing is that that is integrating in part of with respect to time, and in inverse Fourier transform, that is integrated with respect to omega or frequency, that means d omega. And another thing, that is 1 by twice pi, that is the full cycle of a circular or periodic form of sinusoidal or cosinusoidal or trigonometric expressions. So 1 by twice pi integration towards minus infinity to plus infinity, x omega e to the power plus j omega t and d omega. So the preceding equation is sometimes referred to as Fourier transform synthesis equation, or known as inverse Fourier transform equation. As a matter of notation, to denote a signal x has a Fourier transform x, that means xt, that is CTFT, you will get x omega, that I have written before. So as a signal x is Fourier transform x constitute, that is called a Fourier transform pair. That means all of the signals has some Fourier transform pairs, and if you just memorize and study at your own, you could usually find out the Fourier transform of a signal. So thank you very much for being with me. I will give you some extra lessons about Fourier transform and some functions with Fourier transforms to solve some equations.